Thank you. So I'm going to be very short because we, as you can see, we don't have so much time. So this is the work that we did basically with Romain. As you can see, this is an organizer submission, so it's not in the official ranking. And we decided that although it was Romain's work, we wanted to know which faces was the most memorable between the two of us. So this is why I'm presenting instead of Romain. So first of all the systems that we submitted are only image-based, so nothing is video-based. This is because we ran basically out of time for the submissions. So what we decided to do was to extract 7 frames, 1 per second, and all the system were trained on these frames. And at the end, we predict 7 scores, and we just average the 7 scores all together to get a video score. So this is because we ran, as I said, because we ran out of time, but this is also because if you had a look at the data set, you will see that the shots are very short. You have only one scene, one action, one event globally per shot. So we thought that temporal evolution might not be so important. That was probably an issue that we had in the end. So basically, we had 3 research axes. The first one was to add some baselines because we were organizers. So we wanted to see how already existing models were doing. So we took MemNet. You have heard of this from the previous presentations. So it's something that is already existing. It was trained on a large-scale data set. And we just reuse it as is on the frames from the video. We also took another one, which is already existing in the literature, so it's RAN2. This one has shown better performances than MemNet so far. It's also trained on LamMem, sorry. And what is interesting is that it uses semantic in the features through what is called image captioning features. So it's basically it's features that comes from a model that was trained on image captioning task. So for these 2 run, no training, as I said, and no distinction between short-term and long-term memorability. It will be the same runs. Then second research axis, what we tried to do was to see which features were the best. For this, we tried individual network for all of the features that were provided in the task. Plus, we also added, still with the idea of seeing what semantic was bringing to the task, we added image captioning features. So you can see that we have indeed 2 runs that we kept in the end. So the first one is from features that only comes from the images. And the second one is when we added also the captions, because using the using the image captioning model, you can have image and text embedded features. And the last run was very simple. We just took ResNet and retrained it from LamMem, but also from the images of the DevSet video. So this is the result that we got. As you can see, ResNet was performing better. I'm just going through all the usual conclusions that short-term works better than long-term, etc. Image captioning was also doing well. We were quite surprised. Going on to the conclusion, we were quite surprised that multimodality was not working well. We were expecting better results for this. Or it could be that once again we didn't really took time to train the network for this. So we might do better in the future. What to say else? I think that's it. Okay, thank you.